Okay. Next, we want to discuss the shortest path concept. Okay. So we want to find there is a graph shortest path concept. For example, there is a graph, then we want to find the shortest path from one vertex to another vertex. How it is possible? Okay. There is a graph and we want to find the shortest path from one vertex, for example S, to all other vertex or to some other vertex. Okay, that's our task now. Okay, you can note here this is S and there are other vertex also. Then this is here using a directed edge. Okay, directed edge is using, and a weight is attached to the directed edge. Okay, so a weight is attached to the directed edge. Then we want to find the shortest distance from the source S to all other vertex. Okay, S to T is there, S to X is there, S to Y, S to Z. We want to find the shortest distance. So in order to find the shortest distance, we will use which algorithm? We will use Dijkstras algorithm. Okay, Dijkstras algorithm is used for finding the shortest path in a graph. Okay, and another algorithm is also there, which is called the Bellman-Ford algorithm. Bellman-Ford algorithm is also there. Okay, so first we want to discuss Dijkstras algorithm. Then in the next class, we want to discuss Bellman-Ford algorithm. Okay, so one thing is the Dijkstras algorithm is suitable for edge having positive weight. Okay, you can note here these are all positive weighted edges. Okay, but it is not suitable for handling negative weighted edges. Okay, so to handle the negative weighted edges, we need other algorithm that is called Bellman-Ford algorithm. Okay, that we will discuss in the next class. Okay, so okay, please give attendance in the chat box. Okay, please give attendance in the chat box. Okay, Akash. Akash absent ആണോ? ഫാസ്റ്റ് ആയിട്ട് ചാറ്റ് ബോക്സിലിട്ട അറ്റൻഡൻസ്. Akash. Next. Akash, Abhinav. Next. ഫസ്റ്റ് അവർ ആണ് അറ്റൻഡൻസ് വരും. ആകാശ് ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. നെക്സ്റ്റ് അഭിനവ്, അഭിനന്ദ്, please give attendance in the chat box. Okay, Abhinand. Okay, Akash absent ആണ്. Abhinand. Next, Anugrah. Okay, Adarsh absent ആ. Adarsh absent ഇട്ടിട്ടുണ്ട്. അദ്വൈത് പ്രസന്റ്. ഓക്കെ, നെക്സ്റ്റ് നിങ്ങൾ ചാറ്റ് ബോക്സിൽ അറ്റൻഡൻസ് ഇട്ടോ. ഫാസ്റ്റ് ആയിട്ട് ഓർഡറിൽ ഇട്ടാൽ മതി. അജ്മൽ, അഖിൽ സി പോൾ, അനക, അഞ്ജലി. ഓക്കെ ഓക്കെ, നെക്സ്റ്റ് അതുൽ. ഓക്കെ, ദേവിക, ദിൽന, മസ്ന, ജസ്ന ആബ്സെന്റ് ഇടുന്നുണ്ട്. ജസ്ന പ്രസന്റ് ആണോ? ഓക്കെ. ജസ്ന. നെക്സ്റ്റ് കീർത്തന, കാർത്തിക്, മുഹമ്മദ് സിനാൻ. ഓക്കെ. മുഹമ്മദ് സിനാൻ, ജസ്ന ഷെറിൻ. നെക്സ്റ്റ് ജസ്ന ഷെറിൻ. ആഫ്റ്റർ ദാറ്റ് മുഹമ്മദ് ഇജാസ് ആബ്സെന്റ് ആണോ? അപ്പോൾ ഇജാസ് ആബ്സെന്റ് ഇടുന്നുണ്ട്. ഓക്കെ. നെക്സ്റ്റ് ജസ്ന ഷെറിൻ. നെക്സ്റ്റ് ജസ്ന കഴിഞ്ഞിട്ട് ആരാണ്? ജസ്ന കഴിഞ്ഞിട്ട് ആരാണ്? ഓക്കെ. നെക്സ്റ്റ് ആരാണ്? ജസ്ന കഴിഞ്ഞിട്ട് അറ്റൻഡൻസ് ചാറ്റ് ബോക്സിലിട്ടെ. റൈസക്കാരിത് പ്രസന്റ് ആണോ? റൈസ, റസാന, പ്രണവ്, പ്രണവ്സി ആബ്സെന്റ് ഇടുന്നുണ്ട്. പ്രണവ്സി ആബ്സെന്റ്. റൈസ, ഖാലിദ്, റസാന, നിഹാല. ഓക്കെ. നെക്സ്റ്റ് റിസ്വിൻ, റോഷൻ. റിസ്വിൻ ആബ്സെന്റ് ഇടുന്നുണ്ട്. റിസ്വിൻ. നേഹ ബി, അല്ല സോറി, സഹല ബി. ഓക്കെ. നിതിൻ ബാബു. ഓക്കെ. നേഹ. ഓക്കെ. അതിന് പ്രസന്റ് ആണ്. നേഹ പ്രസന്റ് ആണോ? ഓക്കെ. നിതിൻ ബാബു. ഓക്കെ. നെക്സ്റ്റ് റിസ്വിൻ ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. നെക്സ്റ്റ് സഹല ബി ആബ്സെന്റ് ഇടുന്നുണ്ട്. സഹല ബി ആബ്സെന്റ്. നെക്സ്റ്റ് സഹലാൻ. ഓക്കെ. സംഗീത്, സാരംഗ്, ഷറുണ്, ശ്രദ്ധ. സംഗീത്, സാരംഗ് ആബ്സെന്റ്. സാരംഗ്. ഓക്കെ. ഷറുണ്, ശ്രദ്ധ. ഫാസ്റ്റ് ആയിട്ട് ഇടാൻ. ശ്രദ്ധ, വൈഷ്ണവി, ബേബി ശ്രീഷ്മ, അഞ്ജിത, ഷിറോണ. ഓക്കെ. ആബ്സെന്റ് ഈസ് ആകാശ്, ആദർശ്, ഇജാസ്, പ്രണവ്, പ്രണവ്സി, റിസ്വിൻ, സഹലാബി. ഓക്കെ. ബാക്കി ഞാൻ ചാറ്റ് ബോക്സ് നോക്കിയിട്ട് അപ്ഡേറ്റ് ചെയ്യും. ഓക്കെ. Okay, so this is the shortest path algorithm. In the shortest path algorithm, you can note here, this is the initialization step. Okay, in the initialization step, we want to do these things. Okay, we want to initialize a single source. We want to initialize a single source, so we are performing it on graph G. W is the weighted edge and S is the start vertex. We want to initialize the algorithm on the start vertex. Initialize single source G of S. Okay, that is, we want to initialize the graph at first. Then we want to set the variable s is equal to empty. Okay, then we want to set q is equal to g dot v. Here also there is a priority queue. Okay, like in the previous example, prim's algorithm, we are using a priority queue. Okay, we are using a priority queue. So these constitute the initialization step. Okay, these are the initialization step, and this initialization step is similar to the Prim's algorithm case. That is, we want to initialize the key value of each vertex to infinity and its pi value to nil. Then after we want to set these things. Then we want to do these steps 4 to 8. 4 to 8. This 4 to 8 is in this loop. That is, first we will check whether the queue is empty or not. Okay. First we will check the queue status. If the queue is not empty, here we are using the priority queue. Same concept we applied in the Prim's algorithm. The same concept we are applying. Okay, priority queue concept we are applying. Same concept. So first we want to extract the minimum element from the priority queue. U is equal to extract min of q. Okay. After extracting the minimum element, we should add that vertex to the S. We want to add the vertex to S. Okay. S is a set. Initially it is empty. Okay. S is initially empty. We want to add that extracted vertex to set S. Then for each vertex, V belongs to G dot adjacent of U. Okay. So for each vertex, V belongs to G dot adjacent of U. What is this meaning? We want to process each adjacent vertex of U. Okay, we want to process each adjacent vertex of U. So this is that belongs to G dot adjacent of U, which means we want to process each element of each adjacent vertex of U. So next we will call a function relax. Okay, next we will call a function inside the loop body. We will call a function relax U comma V comma W. So what is U? U is the processing vertex. Okay, now we are processing U. Then V is the adjacent vertex. Then W is the corresponding weight. With this, I will call relax. Okay, relax is another function, and this is the body of the relax. Okay, relax function. So it will first check if V dot it will first check. So this is U and this is V. Okay, this is U and this is V. Then there is a distance between, suppose this is the weight W of U comma V. W of U comma V. This is the weight value between U and V. We are processing U. Okay. Then V is the adjacent vertex. Okay. V is the adjacent vertex. And a distance value is attached to each node. Okay, this is U dot D. This is V dot D. V dot D. And what is D? D is the distance value of a node. Like key. In the previous example, we used key. In the Prim's algorithm, we used U dot key. Okay, so here we are using d. D is the distance variable. Okay, d is the distance variable. D is the distance variable, and distance variable is attached to each node. Okay, so next what we want to do, so this is the situation. Now what relax function will do? Now relax function will check if v dot d greater than, that is v dot d is basically this one. Okay, this is v dot d. This is v dot d. This is the neighbor. Okay, this is the neighbor or adjacent vertex. So if v dot d greater than the distance of this function, sorry, this node or this vertex is greater than u dot d. Okay, u dot d is the this one. Okay, that is, now we are processing this node u. Okay, u dot t plus wub, that is u dot t plus this distance. If v dot t greater than u dot t plus w of uv, then we want to update v dot t. Then we want to update v dot d. V dot d distance we want to update. Okay, we want to update this distance. We want to update this distance. Okay, we want to update v dot d. Also we want to set v dot pi is equal to u. V dot pi is equal to u. Okay, this is the relax function. For each neighbor of u we want to do it. Okay, so you can note this algorithm. For each vertex v belongs to g dot adjacent, we want to call this. Okay, then we want to apply this concept of relax. Okay, so this is the Dijkstras algorithm. In the first part we will initialize the graph and graph S and Q. Then next part we will use a while loop. In the while loop we will extract the minimum and do these things. This is the body of while loop, and there is a for loop here. In the for loop we will call relax, and what relax will do, relax will perform this task. It will update the weight of v. Okay, update the weight of v. You can note this is u and this is v. This is the concept. Okay, so now we can move to the example. Okay, this is an example of Dijkstras shortest path distance working. Okay, so initially, so this is the algorithm, and what is the situation initially? You can note here. You can note here. Initially, the start vertex is initialized to 0. Okay, the start vertex is initialized to 0 initially. Okay, the start vertex is initialized to 0. Okay, start vertex is initialized to 0. That is, start vertex distance is 0. Okay, and its other vertexes are vertexes distance. Okay, these are all the distance values. These are all initialized to infinity. Okay, that is the initialization step doing. Okay, during the initialization step, start vertex is initialized to 0, and all other vertexes distance. Okay, inside the circle distance is written. Okay, you can note here, this is basically inside the circle, inside this one, this is actually D of that node. This is actually D of that node. Okay. So the graph is initialized in this way. The graph is initialized in this way. Now we want to process the graph using Dijkstras algorithm. So it is initialized in this way. Okay. The graph is initialized in this way. Next, we want to start from the source vertex. S. S is the source vertex. Okay. So what I will do first, you can note here what will be the status of Q. I told we are using a Q. Okay. We are using a Q. Then the Q will be initialized with the start vertex S, then T, similar to Prim's algorithm. T, X, these are all vertex. This is a priority queue, and here corresponding to S, we are using D. D is the distance of that node. So initially S value is 0, T is infinity, X is infinity, and so on. And so on. There are a lot of vertices are there. S, T, X, Y, and Z. Okay, Y and Z. Y and Z is there. Y and Z is here. These are all also infinity values. These are also infinity. Okay. So this is initialized in this way. Now what is the step? First step in the algorithm. So this is the initial situation. Okay. There is a queue. Queue status is in this way. Now what we want to do in this in our algorithm, what we want to do, we want to first execute this step while q not equal to empty. Okay, the queue is not empty now, so we will do this step. What is this step saying? Extract the minimum from the queue. So which is the minimum here? Which is the minimum here? Which is the minimum one? This one, S. Okay, S is the minimum. So we will take it outside. We will take it outside. That is U, our U. It is stored in a variable U. Okay, so now U is equal to S. So it is taken out from the queue. Okay, then we want to do this loop. Okay, you can note here we extracted the minimum value from the queue. Then we add that vertex to S. Okay, then we want to add S to U. Now, what is S? S is equal to U. Not U here. S. S is a set of vertices, and it is added to that set. Now S is equal to S. Next, for each vertex V belongs to G dot adjacent of U. That is, we want to process the adjacent vertex of U. Okay, so we want to process this vertex T and Y. Okay, you can take any order. Okay, you can take any order. Process the vertex, adjacent vertex of S, and update T. Okay, update the distance. You can note here, I want to update this. Okay, I want to update this also. Okay, this is infinity basically. This is infinity, but now it is 10. How it becomes 10? We can check that. Okay, so suppose I am taking this one at first. Okay, then I taken one adjacent vertex. Okay, for each vertex we want to call relax, and relax will do these things. Okay, relax will do these things. That is, if v dot d greater than u dot d plus wuv. Okay, it will check that condition. What is v dot d? That is, initially v dot d is infinity. Infinity greater than, what is infinity? Why it's infinity? Because this one, this value, that is t dot d, in this case t dot d, because t is the neighbor we are processing. T dot d, which is infinity now, which is surely greater than u dot d plus wuv. What is u dot d now? It is 0, 0 plus 8. Okay, 0 plus 10. 0 plus 10. Okay. 0 plus 10, which is 10. It is greater than. So we want to update t dot d. Okay. We want to update t dot d. Now what is t dot d? Now what is t dot d? You can note here, and this condition is satisfied. So we want to update the neighbor's distance. Neighbor we are processing is neighbor's distance to u dot d plus wuv. Okay, the same, this one, same. Okay, so we want to update the distance of v. Here t dot d is equal to 10. T dot d is updated to 10. Okay, now we got this value 10. Okay, we got this value 10. Then what we want to do? We want to process this one. We want to take next vertex and process it. Same procedure. Okay, so in that case, what will happen? In that case, what will happen? ആയിരിക്കും പറയാമോ? മസ്ന ഒന്ന് പറയുമോ? അല്ലേ മസ്ന നെക്സ്റ്റ് എന്താ ചെയ്യുമെന്ന് പറഞ്ഞേ? നെക്സ്റ്റ് നമ്മൾ ഏത് വെർട്ടെക്സ് എടുക്കുക?
മിനിമൽ എലമെന്റ് എടുക്കും, y എടുക്കും.
അതായത് നമ്മൾ ഈ ഒരു നൈബറെ പ്രോസസ് ചെയ്ത് കഴിഞ്ഞു. ഓക്കെ, നെക്സ്റ്റ് ഏതാ എടുക്കേണ്ടത്? y എടുക്കും. ഓക്കെ, അപ്പൊ നെക്സ്റ്റ് yന്റെ ഡിസ്റ്റൻസ് അപ്ഡേറ്റ് ചെയ്യണം. അപ്പൊ അതിനുവേണ്ടി എന്ത് ചെയ്യും? y ഡോട്ട് d എന്താണ്?
5
അല്ല, ഇപ്പോഴ് ഇനീഷ്യലി ഇപ്പോഴെന്താ ഉള്ള? ഇൻഫിനിറ്റി ഗ്രേറ്റർ ദാൻ 0 പ്ലസ് 5 ചെയ്യും. അപ്പൊ എന്ത് കിട്ടും? 5 കിട്ടും. ഷുവർലി ഇൻഫിനിറ്റി ഗ്രേറ്റർ ദാൻ 5 ആയിരിക്കും. സോ എന്ത് ചെയ്യും? y ഡോട്ട് d എന്തായിട്ട് അപ്ഡേറ്റ് ചെയ്യും? 5 ആയിട്ട് അപ്ഡേറ്റ് ചെയ്യും. ഇതാണ് ചെയ്യുന്നത്. ഈ ഒരു പ്രോസസ്സ് നമ്മൾ ഓരോ നൈബറിന്റെ മുകളിലും അപ്ലൈ ചെയ്യണം. ഇത് ഇനീഷ്യൽ കേസ് ആയതുകൊണ്ട് കുറച്ച് സിമ്പിൾ ആണ്. ഓക്കെ, ഈ ഒരു പ്രോസസ്സ് മനസ്സിലാക്കുക. ഓക്കെ, താങ്ക് യു മസ്ന. സോ ദിസ് ഇസ് ദ functioning, this is the working. Anyway, so in this way we updated the distance of the neighbors. Then what we want to do? Okay, now we are going to the priority queue. Okay, so what will be the priority queue now? The priority queue will be like this. Okay, the priority queue also get updated. So now S is removed from the priority queue. Now T is there. Okay, T is there. Also Y is there. All other vertex are there, but we are now interested in T and Y only. Okay, X is there. Then Z is there. So what about the distance value? Now the distance value of T is 10. it is updated from infinity to 10. You can note here it is infinity, now it is 10. Okay, similarly this value also updated. Okay, 5. Others are still infinity. Okay, now this is the situation of the priority queue. Okay, so we can go to the algorithm. We process this part, then we go back to this. Then again we will check the status of queue. Queue is not empty. We will extract the minimum. Okay, so which is the minimum value now? This one. Okay, y is distance is minimum. So we should take this one out. Okay, that is you can note here this direction. You can note here because y is minimum. You can note here q is in this situation and this is the minimum value. Okay, this is the node with the minimum distance. So we want to take it out. That is, we want to process y next. Okay, so we moved from s to y. Okay, now we reached here. Okay, now this is the source. Now this is the source. Now this is u. Okay, so not source, u. Okay, so from u again I want to update its neighbor distance. Now it is u, then I want to update it again. Now u is equal to this one, then s is updated to v. Okay, next we want to process this one. We want to process this one. Okay, so we want to process each neighbor of y. Then we want to process each neighbor of y. Similar procedure. First we will take this one. Then we will update the distance. Okay, then we will take this one. We will update the distance. You can note here this is 8, this is 14, this is 10, this is infinity. It is updated in this way. Similarly, this also updated. Okay, this also updated. So after updating, what we want to do? Select the minimum. Okay, select the minimum. You can note here. After updating, the status is given here. 8, 14, 7 is the. Then next, which node I will process? After updating the distance, here you can note the distance value is updated within it. Okay, this value is updated within the circle. Okay, now which node we will process? We will process the distance with the minimum value. Okay, which is it now? 8, 14, 7. So 7. So Z is the next node to be processed. So we moved to Z. Okay, we moved to Z. Then we want to process this one. That is, we want to update the distance of this and this. Okay, so we will apply the same concept. Then we will update these distances. Okay, this is 8. After updating it, we will get 8, and this is changed to 13. Okay, we will apply the same concept. Okay, that is the relax function is applied on the neighbors. Then we will get 13. Next, what we will do? We will process which node? We will process this node, which 8 and 13 is the minimum of it is 8, that is t. We will process this one. Then we will update the neighbors. Update the neighbors. So update the neighbor means we want to process this one only. Okay, we want to process this one only. then we will move to here. So we will get a graph like this at last. Okay, so inside this vertex the distance is updated. So reaching from S to 5, S to Y 5 is the distance, S to X 9 is the distance, minimum distance. Okay, 9 is the distance. Okay, anyway, next class we can discuss one more class we needed to discuss this algorithms. Okay, okay, thank you. Okay, thank you.